Welcome to the final chapter of Kubernetes learning series. In part 1, we learned about Kubernetes and workloads in general, along with some open source tools. In part 2, we learned about approaches for attacking Kubernetes clusters from a red teaming perspective and also understanding attackers' mindset while exploiting clusters. Today, we'll dive deeper into practical strategies of defending a Kubernetes cluster so that we get an idea of how to defend a cluster and also some of the best practices to follow while defending clusters from attackers. Divyanshu, welcome back to the show. Looking forward to the final part of the series.
Protection we have already seen about the RBAC. We have performed the scan, so we are not going to look into the all the security basically protection strategies. We'll talk about some of them. So we'll start with the network policy, and network policy is how the traffic is communicating within the pod, or how
Mhm.
flow of data is happening from one cluster to another cluster as it is required. Then we'll talk
Right.
about RBAC security, which we have seen again and again. So I
Mhm.
won't be talking about RBAC. Then the secret management, we will look into the secrets, how the secrets are mounted, and how we can use the sealed secret to store the secret directly in the YAML. And then we look into the Kyverno, which because
Okay.
Kyverno is extremely simple to set up, and like it is easy to perform the validations and enforcements on the top of that. And last would be
Okay.
Cilium. So Cilium is the network fabric which we have been
Mhm.
using in our lab. Like we created setup on the top of Cilium itself. So we'll see
Okay.
how like the Cilium would work, and like we'll talk about the mesh and app armor, the security context. But
Okay.
other than that, I don't think we can talk about, because they are extremely exhaustive. Like if we'll talk about mesh, then we have to show the mesh, like how these things work. What do we mean by mesh?
Right.
This is pretty much advanced. But
Mhm.
for now, we can look into these the network policy, and then the secret
Mhm.
management, and possibly the Kyverno and the Cilium. These four things we'll
Okay.
look. So let's get
These
started
four in
with
itself
the
feels like a lot. So
yes,
let's go
yes.
through one at a time. Yeah.
So the easiest one is the network security policy. It is called as NSP. So based on the
Mm-hmm.
pod selector or the label, and then how the traffic is flowing, whether it's an ingress or the egress traffic, we
Mm-hmm.
can have a network security policy based on the
Okay.
source IP, destination IP, port number, and protocol. So we can allow and deny the rules, but it is not as exhaustive as Cilium, because here if I want to suppose block an endpoint, right, I want to block any specific API to be accessed even within the cluster itself. So
Okay.
in those cases, I can't use network security policy. Or if I want to block a specific layer or something very specific, right, maybe an header. In those cases,
Mm-hmm.
I can't use a network security policy. So for that, your this Cilium would come into the picture. But for
Okay.
basics, we can always go with the network security policy. So Cilium would give basic network security policies plus all the advanced like protection strategies which we are looking for. It will also help
Okay.
us to monitor the cluster traffic as well.
Okay. So for a beginner, maybe network
Hmm.
security policies makes more sense.
Correct.
But as you
Correct.
get into advanced use cases, look at Cilium.
So
How Cilium can help.
it is basically having a Hubble UI which helps us to monitor, or like it helps us to understand how a flow is happening when a policy is getting created, like from where the
Okay.
traffic would flow. It won't exactly show you the real time data, rather it is
Mm-hmm.
more towards showing you how the, like if I'll create a policy maybe from pod 1 to pod 2, I want to block
Mm-hmm.
the traffic. So I just want to see no, if I'll create XYZ thing, whether it will work or not. So for that we have a
Right.
Hubble. So we can just write that YAML, paste it, and it will show whether that policy is exactly working in the way or not. So it is
Okay. So in
much
a
more
way,
in. Hmm.
simulate it and show
Correct, correct,
you whether the
correct,
policy is valid or not.
correct,
Okay.
correct.
That's interesting. Hubble
So
UI.
let's get started with the
Yeah.
network security policy. So we'll be blocking the ingress traffic based on the source pod level. I'll
Okay.
explain the objective. There are two namespaces, namespace A, namespace B. Each
Mm-hmm.
namespace houses an Nginx pod
Mm-hmm.
named app A and app B.
Okay.
We have label app A namespace A and name app B namespace B, and both are running the Nginx pod. and
Okay.
we'll see that initial connectivity is there between the app A and app B. And then
Mm-hmm.
once we implement the network security policy in the namespace B, it would block the ingress traffic from any pod with the label of app A. So if my pod would have
Okay.
a label of app A, then I won't be able to communicate to any pod in the namespace B. Then
Okay.
we'll retry to access the application or like the pod app B from app A, and we'll see like whether we are able to access it or not.
Okay. So in a way, we are trying to block connectivity
Correct.
between two
Yes,
pods.
correct.
Okay.
So this is the YAML which I wanted to show. Let me just go into the 7.1. So this is the demo policy. If you'll see,
Okay.
like I'll just, this is for the explanation that there is a network security policy of kind
Mm-hmm.
this. Then
Mm-hmm.
deny ns2 is the name. Then in which namespace it will operate, and what is the
Mm-hmm.
policy type, ingress, and from where basically the match label should be. So you'll say
Okay.
namespace selector match label is ns2, and here
Mm-hmm.
the ns1. So anything which is coming from ns2 to ns1, and the type is
Right.
basically the ingress.
Right. Right.
So I have mentioned the same. I'll just read it
Okay.
out loud. That I'll basically read this, the ingress part, from and namespace
Mm-hmm.
selector with match label name. NS2 means align incoming connection from any pod in namespace that have the label NS2. However, as there are no specific ports defined, this effectively denies all incoming traffic from namespace NS2 to NS1.
Okay.
So
So
NS2
it's
to
like
NS1, it will
wildcard
block
deny.
all traffic
You are
because
not
I
denying
have
a particular
explicitly
port.
said.
You are just denying it entirely.
You were saying something, Pushottam.
Yeah, I was just saying it's not wildcard. It's like, sorry, it is wildcard. You are denying
Correct,
everything, not
correct,
just a particular port or something like that.
correct, correct,
Okay.
correct. So I'll just create two namespaces very quickly. I'll be
Okay.
very quick.
And if I need to, let's say, block a particular port, how would I
Mhm.
do that? Like, do I need to add port information there?
Yes.
Okay.
So we'll need like those informations. If we don't have, then we have to find like where the communication would happen, and then based
Mm-hmm.
on that, we have to add those things.
Okay.
So I'll just run the command, and I'll show you. If you'll see, I'm trying to access no this. I'm doing a curl basically,
Okay.
and from the namespace is namespace A and
Mm-hmm.
app B. So basically, I'm trying to access app B in the namespace B via this
Okay.
service name, and like the namespace is namespace A. So it is just doing a curl. So you'll see it is
Mm-hmm.
showing me the Nginx is basically welcome to Nginx, right? Which is the default. So
Right.
it shows that I'm able to access my application
That
app
page.
B. Yes, pod B.
Right. Right.
Basically, I'm able to access. Then I'm
Correct.
implementing the network policy. So it will see this network policy. It is the exactly same thing. It is telling me in
Mm-hmm.
the namespace B, specifications app B, and from app A. So if
App
anything is
A.
coming from
Okay.
app A to app B and the type is ingress, then block it. So I'll just use the cat
Right.
UF to create and apply the policy directly.
Mm-hmm.
And now when I'll try to access, let's see whether I'm able to do it or not. So you'll see this time I'm not getting output.
Right.
It says
It's
download
timing out
timeout.
there.
Correct. So this shows
Right.
like extremely simple network security policy.
Mm-hmm.
And I'll delete this so that we can run our next lab. But before that, if any
Sure.
question you have or anything.
Yeah. So one thing is, what are
Mhm.
some of the use cases you have seen where the these types of network restrictions are applied?
So I
And
mostly.
if you want to
Mhm.
exclude a particular app, let's say you
Mhm.
want to exclude 5 apps, but you want to
Mhm.
allow a particular app, can you use network policies for that as well?
We can use, because apps would have labels and no IPs, or they have like similar structure, so we can do that. But usually I haven't seen I've seen people using Calico or Cilium for
Mm-hmm.
most of the times, because companies from the initial stage itself, they want to have a cluster with advanced uh, network fabric, so that
Right.
later, or even if they want to have a network security policy, I haven't seen folks using NSP. like at least in my
Okay.
experience, I haven't seen if
Okay.
someone has implemented it, then like they can definitely have discussion, they can like tell the blog if they have written. So because
Mm-hmm.
most of the times, even when I started into the Kubernetes security, at that point of also the company implemented, like there was no security policy, and the first thing they came up with was Cilium, because of this eBPF
Okay.
technology, which I'll
Right. Right.
explain
Right.
later. Yeah. So and
Mm-hmm.
in Calico also, if you'll see, they have anomaly detection and all that, like which is pretty much advanced. Like if we not talk
Okay.
about Cilium and we'll talk about Calico, in those cases they have detection mechanism in their enterprise, and they, that is also very much advanced, right? It will give you
Okay.
monitoring, and like if I'm talking about anomaly detection, obviously it is monitoring all the traffic.
Correct. Correct.
So
Yeah.
those things like are given by these no network fabrics which are advanced. So I
Mm-hmm.
maybe like people are using for their basic setup, or if they have something no very like limited, or if they are doing it for the first time. But whoever
Mm-hmm.
wants to implement a robust security, network security, they always use like some kind of advanced fabric.
Okay. Makes sense.
So next is the secrets. So I'll quickly
Mm-hmm.
explain the secret. So secret is anything which we want to keep secret, and in Kubernetes it is stored in the base 64, and
Right.
because it's base 64, so it is very easy to get it and decode it. Like it is
Decode it.
equivalent to plain text. So if I'm storing some secret in the Kubernetes and then uploading the same into the GitHub, so it is
Mm-hmm.
very much easy to for an attacker to search that GitHub, or if that secret is leaked, in that case it would be easy for anyone to decode that base 64 value and find out what is the secret. So I'll show you how
Right.
basic secrets work and how it is mounted into the container, and we'll talk
Okay.
about some secret management tools like vault and all that, but we'll primarily look into the sealed secret, which is a binary provided by Bitnami, and it is basically used to encrypt the secret. Because the secret is encrypted, it is much more easy to upload that secret into your GitHub, right? So if encrypted
Right.
secret
Right.
is leaked, in that case anyone won't be able to decrypt, until unless obviously they don't have access to your cluster, because your
Right.
Bitnami pod would be running in that cluster, and I'll explain the how basically that tool works, or that
Yeah, yeah, I
container.
have that question that if it is encrypted, then how will my pod get the decrypted value? But yeah,
Sure.
I'm sure that you will show that.
Sure, close my NAT. So let me go into the secret folder, and I'll just close these tabs.
Sure. Yeah.
This becomes like my browser where I have thousands of tabs open.
Yeah, everybody
Correct. I've
goes
seen
through the
like
same pain.
correct, everyone, no, whoever is working in IT, like they have
Hmm.
this thing. They have like thousands of tabs in on Chrome and no Firefox open.
Yeah, yeah.
So I'll just create a directory this time, because like here we don't need anything else. Like whatever we need,
Okay.
we will create it. So I'm just to keep things clean, I'm just creating a
Hmm.
directory, and inside that I'm just creating two files, username.txt and password.txt, and echo the admin and password value. That's it.
So this sort of shows, let's say, if you have a key
Correct.
and secret or something like that, those are stored in those files.
Correct. So if you'll see password.txt, I have password, and in the
Right.
username.txt, I'll have admin.
Right.
So I'll create the secret. The type is generic. So
Hmm.
we like the way we create everything, right? I'm creating a secret and I'm just giving the generic type. There can be different types, but for now we'll focus only on the generic, because then we
Okay.
will move in a different direction. So I just want to
Okay.
keep this sorted. So I'll just
Sure.
quickly create the type generic, like the secret
Okay.
type generic, and this is the name of my secret, KTS
Okay.
user pass. And from
Hmm.
I'm passing the file, which file I want to use. You will say it has created the secret, like service, like no pod, you can have the same. Similarly, you will have secret and name of the secret,
Okay.
and then I'll do a kubectl get secrets, and it will list me what kind of secret it is, and
Hmm.
you will see the data also. It is 8 bytes and 5 bytes. Now if I'll
Right.
upload this, so basically I'll explain one more thing. So if you'll see, the type is also the opaque, right? This is
Right.
another thing. So if I want to get this secret, so I'll again do the same thing. I'll just do the kubectl get secret, and name
Hmm.
of the secret. Here I just did get secret, so it listed me which are all the
Right.
secrets present. but here I'm
Okay.
getting the specific secret and saving it in the YAML. So when I'm saving
Ah,
it in the YAML, you will see there is password.txt and username.txt in the base 64.
right.
So
So you
if
can
I'll
easily decode and see
correct,
the
correct.
value.
So if I'll upload this YAML anywhere, it would be like stored, right? And anyone can
Mm-hmm.
decode it, even if it is not uploaded, and even if this is present in my cluster. As an attacker, I
Mm-hmm.
can dump it.
Correct. Correct.
So I'll just use the command to decode these values,
Mm-hmm.
and I'll just use this echo command to keep things clean a little bit, and it
Sure.
will show that I have just decoded. So I got the value of
Hmm.
secret, and then from there I've like grabbed the password.txt output, and here I am
Right.
just using the hyphen d and passing that username value and the password value. So I'm just
Right.
using first output is the variable name of username and password, and second I'm using that values and passing it to the base 64 hyphen d command to decode this, which is saying the
Right.
username is admin and the password is password. So you
Yeah.
will see
Imagine
how.
this being
Mhm.
imagine this being AWS secrets, right?
Correct, correct,
So now you have access to someone's
correct, correct,
AWS
correct.
account in a way.
Right, because we are seeing the fake credentials, so that might be easy.
Right.
But in real world, if they'll have keys or something which is required, and like the no the infra team, or they don't know exactly like whether how easy it is to get this secret, they might be creating something like this.
Correct. Correct.
So now we'll see if we'll create a db.secret YAML, and if
Mm-hmm.
we'll use it in real world, what we can do. So I'll just create this secret. So I'm earlier I just created it via file, and I created, if you'll see here, I passed it from the command. This time I'm
Right.
creating it via YAML. That is the only difference.
Directly manifest. Okay.
Yes, via manifest. So I'll just do kubectl get secret. Now you'll have another secret with the name of db secret.
DB secret. Yeah.
So this time I'll create an application which will use the secret value which we have created.
Okay.
So I'll quickly create this web app.yaml, and where I am
Mm-hmm.
passing this value db underscore password.
Okay.
So let me just show you, and I'll do a kubectl apply hyphen f command to apply this YAML and sleep, just so that my command is complete and we get enough time that our pod is running successfully. Now
Right.
I'll
Right.
do a
Okay.
print env again to show what are
Mm-hmm.
the environment variables. So you'll see there is this environment variable with db underscore password, and the
Password,
name is my key value is my secret password, right?
which we had created earlier
Correct, correct, correct,
using the manifest. So in
correct.
a way, you are showing that how to create a secret. How can
Mhm.
an application, like application as in a pod, get access
Mhm.
to that secret and it gets into the environment? So if it is not secure, then anybody can print the environment and see all the
Yes, correct.
secrets. Okay, that is helpful.
So we'll go back to our lab, and this is pretty much about how the secret works, how we mount it, and we'll
Uh huh.
delete and we'll perform a cleanup, and then we'll
Okay.
look into that sealed secret binary which I was talking about,
Right.
and
Right.
what
Yeah.
what we can do. Like here in this case, because it was in the base 64 format, so I would have dumped it, or like if I would have stored it somewhere, it was easy for me to get that back. But if I'll use
Right.
this sealed secret, we'll see why it is difficult for an attacker to get the data. So you'll see I'm
Okay.
downloading this kubectl binary. I'll do a wget, it will download that binary, then I'll install this binary
Okay.
into the user local
And this
bin.
will be on the on my machine. Let's say as a
Yes, this
developer, if I need
correct.
to add a secret, then it need
Mm-hmm.
a kubectl has to be on my
Correct.
machine. Okay.
So basically, the thing is here, if you will see, I'm doing a wget and then I'm running a controller.yaml, right? So this
Okay.
controller is kind of a API server for bits this sealed secret tool. Let me just show
Okay.
you. I think it is getting downloaded. So okay, what I'll do, I'll just do a wget here itself. I think I've already done that. So let
You have
me just
already
do a
done. Yeah.
cat. Yeah. I what I'll simply show it from here itself.
Sure. Sure.
7.3 secrets. This should be
controller.
much better. Let me zoom in. So you'll see
Mm-hmm.
this will create a service, this will create a role, this will create like cluster role, and it is
Mm-hmm.
telling, it is creating the no like resources, shield secret, what are the verbs, what are
Okay.
the API group. So here it is creating everything kind of a API server. So this would be the brain of your no shield secret.
Okay.
You
So
see,
these are custom like
correct,
extension
correct.
to Kubernetes so that
Correct.
they
If
can
you'll see,
support
this
the
is here it is mentioned, right? Custom resource definition. So I am just
correct,
adding an
correct,
extension. It is very much similar to a Firefox or Chrome extension. Here just I'm
correct, correct.
adding another extension, and but whatever I want, I'll mention everything here. This is a huge file, so
Okay.
I'm not going through
Okay.
it. And then I'll just apply. So here I think I've already applied the cluster. No, let me reset. Yes, I have already applied the controller.yaml into the cluster. Now if
Okay.
I'll create another secret namespace and I'll
Mm-hmm.
try to do the same thing.
Okay. So you
Let
don't
me,
have to define a different type of resource or anything like that.
no, I'll show
You
you.
just
No, no,
okay.
no, we have to do. So we have to do,
Okay.
I'm just creating a namespace, then I'll again create a the secret.yaml,
Okay.
and I am passing the same value test in both the cases, username and password this time. But
Okay.
here you will see a command. So this command
So this
basically
is
I'm
the
using,
key.
yes, so I'm doing a cat secret, then using the kubectl command from my local,
Mm-hmm.
and passing the controller namespace, controller name, seal secrets controller, and the format is YAML, right?
Okay.
And now I'm generating a YAML. So
Okay.
if I'll do a
So it sort
secret,
of reads from your secrets
correct,
file and does the encryption and then gives you a new file.
correct. So if you will see,
Okay.
now the username password is encrypted, and this was
Right.
my
Right.
other previous YAML. So now it has created a new YAML for me.
Okay. Makes sense now. Okay.
So
Now
as
now I'm curious how a pod will access it.
So let me show you that. So this time I have created a secret here again, and now if I'll try to basically, so pod, like if I'll do an cube edit, right, kubectl
Mm-hmm.
edit, so you will see I'm using kubectl to get what is running in that pod currently. So you will see it is in the base 64.
Right.
So my pod will see this file. If you'll see, this is like,
Okay.
but
So at
if I,
runtime, it is sort of the
correct,
same thing.
correct,
Okay.
because I'm doing a kubectl command. Let me
Mm-hmm.
just close it. So because I'm doing a kubectl edit, so this request will go to our API server, right? And from there
Right.
it will go somewhere in the node or do whatever it wants. So
Right.
because we
Right.
have a custom resource definition, so it is trying to edit the secret in the namespace secret.
Mm-hmm.
So this
Okay.
is kind of a runtime, right? Because this thing is already running. So by
Correct.
default,
Correct.
it will do, the controller will do the decryption for me, and it
Mm-hmm.
will show me because we have already installed the custom resource definition.
Correct. Correct. On the
So
cluster.
correct, correct. So that is
Yeah.
how our application would see it. But if I'll have that YAML, you will see this is the sealed
It's
secret
all
YAML.
encrypted.
Yes, if you'll see, this is the secret which I have applied actually.
Right.
So that is how we can store it. So it is solving the problem of storing these YAML, right, with the hard coded
Right.
values. If
Right.
organizations
Right.
do not want to use the no any vault or any kind of key management system, in those cases they can, for the beginning itself, they can use these values. Like if they want to
Right.
go into the advanced phase, they want to have a highly available cluster with no highly available HashiCorp vault, or like any other no like management system they want. In those
KMS or
cases,
something like that.
correct.
Right.
So in those cases actually they have to maintain everything, right? So like
Right.
organizations are little bit hesitant in the beginning to go through or have the vault. Like this is not the
Mm-hmm.
best practices which startups or like companies follow. Like if it is a
Right.
very mature MNC or the company, in those cases they definitely follow this. But if it's a
Correct.
startup or a newly created company, or if something, suppose I am creating a project, right, in those cases
Mm-hmm.
I might be not using vault, right, because then I have to keep
Mm-hmm.
my vault running all the time. So
Correct.
that
Correct.
might not be the case. Or like if I want to create an open source project and want to upload it, or maybe create something internally for the organization, and I don't want to have the vault, so in those
Correct.
cases I can simply use these values, and add
Mm-hmm.
these YAML and even the sealed secret YAML into the cluster, and whenever someone will deploy these, it will deploy the controller, and at the same time this will generate the values for me. And now I can,
Okay.
like, even I'll tell to DevOps that I want to use the sealed secret and I want to store my values in the GitHub. So it again depends how the organization is structured, but this is just a
Correct.
way of storing the secret in the encrypted way.
Yeah, so I see two advantages of it. One
Mm-hmm.
is which you clearly highlighted, right? Even
Mm-hmm.
though you check it in into your GitHub, nobody knows exactly what are the
Correct.
credentials. The
Mm-hmm.
other part is the abstraction. Like as
Correct.
a user of the secret, I
Mm-hmm.
don't have to do anything, right?
Correct.
I'm just accessing it as if I'm accessing a like plain text secret,
Correct.
like Kubernetes
Correct.
secret. So
Kubernetes.
that one follow up question I have is,
Mm-hmm.
now we are using sort of a third party
Mm-hmm.
solution, right? Even though it is open source, what
Mm-hmm.
about the security of that?
At
Like
least
for
I.
Seal, because it must
Mm-hmm.
be managing the private key,
Correct.
public
Correct.
key, all of
Correct.
that, right? How is that secure?
So in,
And
I am not sure. I have not implemented this in the production ever. Like I
okay,
have seen, I've used it for my personal stuff, like for creating something. No, for learning something.
okay,
So I have scanned the YAML, and like YAML was having the necessary permissions which were required, but I'm not
okay.
sure about the binary or no the image. Like I'm hoping
Ah,
basically because it is Bitnami, which is used for the Helm also, right?
correct, correct.
So I'm
Mm-hmm.
assuming, but I haven't performed any scanning of the image itself. So image might be vulnerable if that is not updated, if they have updated a new image, right? Like this
Right.
secret like controller.yaml, if they have a updated version of image, in those cases this might be vulnerable to attacks, so that can happen.
Right.
So I'm not
Right.
sure
So
about
this
that
can be an
exactly.
exercise. This can be an exercise for our audience, right? So that they can play with, like run a scan on the Bitnami images and see if there are any vulnerabilities there.
So by that, in those cases, like even Kubebench or Cube Hunter also are not scanned. So maybe we have to perform the scan, right, for those images
Right. Right.
also. So we, in
Right.
these cases, because they are like highly started, at least I haven't used these in the production because I'm
Mm-hmm.
obviously using the paid tools. So
Right.
like they are, and I'm getting the pen test reports and all these from the vendor itself. But for
Right.
the like testing or for the production, if we are using any open source tool, then we need to have a complete idea of what that tool is doing, whether it is vulnerable or not. So it is
Right.
more like like we have to perform the scan on the images also, and then we have to look whether a backdoor is there or not, because vulnerabilities like Kubebench and also vulnerabilities can be there, right? Because it is not
Right.
updated every day, so that
Mm-hmm.
can be there. But if it is having some kind of backdoor or some malicious thing which gives maybe a reverse shell, in those cases
Yeah.
that
Yeah.
this is extremely dangerous.
Correct. Correct. Okay. No, it makes sense. Let's go to the next topic.
And
I
if
think next
in
one.
Sure.
Go ahead. Go ahead.
Yeah, so in cases basically where we have a cluster monitoring setup via
Okay.
any anomaly detection, maybe like I was talking about Calico. So in those
Right.
cases, we would be seeing some external communication happening, right? If we have
Right.
some
Right.
malicious pod, but if those things are not there, it is a new cluster, then we
Right.
should be extremely careful. And that is a very nice question, by the way, because I
Okay.
have
Thank
done
you.
that. Like whenever I'll do any open source project, I'll install in the prod or even in the staging, I'll definitely go through a check, like because I have
Okay.
not used much of them in the production. Like the sealed secret I've never used, Kubebench and Cube
Mm-hmm.
Hunter I've used. I did a basic sanity, I checked the YAML. I basically used Checkov to perform a scan on those YAMLs. so so I checked those
Interesting.
values, and I saw like when these images were updated, and I just did a trivia scan,
Okay.
and I just keep an eye like about on the hash, no what SHA-256 is there, so these things I'll match. But
Okay.
we if we want to use something explicitly for in our environment, we can have a cosign which is used to sign the container images, and then we
Right.
can upload those values in the private repo, so that we don't have to rely on the public repositories, this Docker run and all.
Correct. Yeah. That makes sense.
So next is the Kyverno admission controller. So admission controller
Mm-hmm.
is basically anything which performs the validation and the like checks what kind of pods or services or whatever it is getting created in the cluster. Like
Mm-hmm.
if I want to suppose create a deployment with without a label, and I want to keep and
Okay.
check, or if I want to have a policy with some xyz name, or if I
Mm-hmm.
want to deploy all things in the xyz namespace, or if I want to block deployment in the default namespaces, right? So
Right.
all these
Right.
things I can do with the admission controller. So it will perform,
Mm-hmm.
it will, the request once it reaches the API server, there are custom CRDs which are installed, and from there either a validating webhook or a mutating webhook will trigger based on the policy which I've created. Like if I want to block something, then it will perform a blocking, right? It will
Right. Right.
enforce it. But if I want to change values, like someone, like as an engineer, like I am creating a pod, so I want, if my label is no Cloudanix, then the label should automatically change to Cloudanix underscore environment or Cloudanix underscore staging or Cloudanix
Okay.
underscore no prod. So these
Mm-hmm.
mutations I can have via the admission controller. So OPA
Okay.
gatekeeper is one open source controller, and Kyverno is another. So Kyverno I prefer because it is having no library with huge YAMLs where the policies are provided, so you can easily go and learn. Uh,
Okay.
and with the OPA gatekeeper, you have to learn the Rego, which is little bit complicated. So if you are starting it for the first time, like when I started
Ah.
learning
Okay.
OPA, it took me some time to pick up the policies. And then in the
Right. Right.
production, when I had to do like 50 or 60 policies, right? In that
Mm-hmm.
case, it was extremely difficult for me to create those policies because I was starting and I have to go through Rego, then I have to test, and I was trying to bypass those policies as well. So for me, it was a
Correct.
lot
Correct.
of work. So
Right.
I switched to keep Kyverno, and Kyverno was having the policies already present in the like if you Google, you will get a library, and there they
Right.
had all sorts of policies. So it was easy for me to copy paste and then change the values which I required.
Okay. So,
So
in case of OPA, you have to learn the Rego
correct.
language and use
OP
that,
is
right? So
actually
that
much
becomes an
more correct. So OP is much more powerful than the Kyverno. Like Kyverno is mostly around the Kubernetes.
right.
OPA gatekeeper can do much more things. Like if you'll see,
Right. Right.
no AWS labs, like their workshop, they use Kyverno for other things also. Sorry, OPA
Mm-hmm.
gatekeeper for other
OPA.
things
Yeah.
also. So
Yeah.
OPA gatekeeper is just one part of the OPA where it is having the admission controller functionality. That's it.
Right. Right. Okay.
So
Makes sense.
we'll talk about validation, mutation, and generation. So I have already explained. I'll re-show
Mm-hmm.
the same like which I was telling. You will see
Okay.
HTTP API handling, then authentication and authorization in the cluster. Then
Right.
whatever the mutating admission is, if that is there, it will happen. Or if
Okay.
nothing, this mutating admission is not there, then object schema validation would happen. And post that,
Mm-hmm.
you will see validation admission is checked, right? And then those
Okay.
things are stored in the Excel, like there
In the
whether
etcd.
like the
Okay.
pod was created successfully or not.
Okay. Okay.
So Kyverno is also having like a similar structure where we have a generate controller and the policy controller, and we'll deploy
Ah.
the custom
Okay.
CRDs. So every tool
Mm-hmm.
they have to have some kind of pod running, right? Or
Correct.
like so that like there is some brain running which will do the evaluation, and this who will basically have the webhook running, which can be
Mm-hmm.
used to perform the like mutations or validations, whatever we want. So I'll,
Correct. Correct.
this is pretty much about the Kyverno. I'm not going into
Uh-huh.
the policies much. I'll explain in a very layman language that whatever rule we have, it will check whether it matches or not, and then it will
Uh-huh.
exclude in the case of matching, and in the case of mutating, first it checks, then validates, and if validation is
Okay.
successful, it will generate the updated value of that, no, whatever mutation we have written, which I'll show
Okay.
like in the lab in the next setup.
Sure. Sure. Yeah.
So here in this part, I'll first like deploy the Kyverno via Helm. So I am not sure
Okay.
if Helm is installed. Uh, I think okay.
Maybe you're not in the
So
right directory.
no, actually this I have. Yes, I haven't opened the new tab.
Okay.
So now it should be working fine. I don't think I have Helm, so I'll also show how to install Helm. I have steps ready. Yeah. I'll
Yeah. You
quickly
do
go
not have
into my
help.
lab, and because this lab I created yesterday, so Helm might not be there. So
Okay.
it is
Okay.
just a one liner. You can get it
Uh-huh.
from the official Helm website also. I'm just using from my lab. So this is the
Okay.
curl no script, and I'm
Uh-huh.
just curling the script which is provided, and it will from the GitHub, and I'll just run it via bash. So that
Okay.
is pretty much it, and it will install Helm for me. So you'll see
Awesome.
it is verifying the checksum it has installed into the user local bin,
Mm-hmm.
and I'll very
Okay. So you have Helm
quickly.
now, and we are
Correct.
installing the Kyverno.
So I'll just use the above command.
Sure.
I'll use this repo add to add the Kyverno repo,
Okay.
and, and then I'll use Helm install command to install it. I think I went, yeah. So it has been added.
Okay.
Now I'll do a Helm install. And it will. So replica count is here set to 1 because this is a testing cluster. If it was a
So you are
real
just
cluster,
setting
then
one pod.
correct,
Yeah.
correct. So if see, you will see a warning also that setting the admission controller replica count below 3 means Kyverno is not running in the high availability mode.
Right. Right.
So this is
But
with
since it is
actually
a testing one, so we are okay. But
correct.
in production, we Kyverno
So
recommends that
we
you have at least 3 replicas.
correct. So it recommends, but we have to decide based on the traffic and based on the communication, right? If we have suppose
Correct.
thousands of deployments happening, then we
Mm-hmm.
might need more replica set. This is for the any like CRT. This is for the Bitnami also. It again high availability is where you have too much of traffic, right? Because we are
Correct.
staging
Yeah.
and like we are testing it, so we can do whatever we want. But in real world, we actually have to deploy all these things and test first whether I'm able to do it or not, or whether my we have to deploy the complete application using this Kyverno, and we have to check whether my application is working as intended. Is there any time difference, or is there my application is taking too much time? So all these things we need to check there. Like
Right.
this is mostly the part of DevOps, and I have included this because I wanted everyone to know how this will work, right?
Right. Right.
So as an attacker, like if I have got the access of the cluster, I can use this
Mm-hmm.
Helm to install the basically I can use the bash to install the Helm, and then I can create my own charts and deploy in the cluster, right? This is another way
Correct.
of
Correct.
deploying the pods or the deployments in within the cluster.
Mm-hmm.
So next is the basics, like how the policies are created. So there are multiple types of policy. First is the
Okay.
enforce policy, like which
Okay.
checks for the label whether label is present or not, or the label is required, like that is mandatory.
Okay. So
So
any workload that you want to deploy has to have labels. Otherwise,
correct,
those will fail in a way.
correct. So you'll see it is the validating webhook which is working. So first I'll
Okay.
do get validating webhook. You will see there are a couple of webhooks running.
Okay.
Kyverno resource
Already. Yeah.
validating webhook is 0, policy validation is there, exception validation is there, and cleanup is there.
Clean up. Okay.
So now I'll see what are the mutating webhooks. So this walkthrough is also about showing what kind of webhooks are present, which are by default
Okay.
installed. So verify
Mm-hmm.
mutating webhook and the policy mutating webhook which is present, right?
Why does it say that webhooks is 0 for one of them?
So that might not be installed by default when we are using Helm, like because
Okay.
Helm would
Okay.
have certain default criteria, right?
Right. 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 Okay.
So now I'll just quickly explain this YAML require underscore label. So we'll
Mm-hmm.
skip all this part, like the kind is cluster policy, and then this is the annotations,
Right.
which is like your definition or description. Then
Okay.
here comes the important part, which is the validation failure action, which is your
Okay.
enforce. So you'll see I'm
Hmm. Hmm.
enforcing it, and the background is true. And I have
Hmm.
mentioned that label deployment is required, and here I'm using the regex. So if with the
Okay.
label deployment, if anything is not there, right,
Mm-hmm.
then basically it should check, and it would fail the
Okay.
deployment. So I'll quickly create this policy,
Okay.
and I'll apply this policy.
Mm-hmm. And again, similar to the
Correct,
Bitnami one, this is a custom definition. So you have to
correct,
apply it in your cluster so that it can
correct.
do the enforcement at runtime.
Correct. So now if you'll see the cluster policy, we have require label, background is true, and the validation action is enforced.
Enforce.
So
Okay.
we are not doing an audit or in the count mode like where we want to have the logs, right? We don't want to block
Right.
anything. In
Right.
those cases, we'll have audit mode here. So
Right.
when I'll try to perform the Kyverno run command this time, I'll just clean my. So you'll see like it is saying the validation error, the label development is required,
Hmm.
and it was
Okay.
blocked due to the following policy. So now you can see it
Okay.
is very easy for me. Now if I'll pass the label this time, I'm not using
Mm-hmm.
YAML, I'm directly running the pod here. So you will see I've
Right.
passed the hyphen label development equal to yes. You can pass anything. You can
Right.
pass
Right.
no anything. Like I just want to have the development equal to as we have
Right.
created, right, in our
Yeah.
policy.
Yeah. In the
Because
policy.
we
Yeah.
correct, we were using wildcard question mark star. If we have used
Mm-hmm.
explicitly yes also, like if we have hard coded that value, then it would take only yes.
Correct, correct. So in a way, we are. This is very similar to how in our cloud infrastructure we say that
Hmm.
hey, you have to follow tags when you
Correct,
deploy
correct,
resources. So
correct,
here you are saying that you have to have a default label,
correct,
development label before you
correct.
deploy. So you can
Hmm.
customize those what exactly you want to enforce for. But yeah, this is one of the examples. Makes sense.
So the next is I'll just delete this cluster policy because I want to create
Sure.
the audit policy. So rest everything would be same almost. Like I'll
Mm-hmm.
explain what things are changing. So validation failure action is this time audit. So now
Okay.
I'm auditing. It won't blog. It will just put it in the logs, like I can see in the log.
Okay. Okay.
And then the pattern is using default namespace is not allowed. And I'm checking
Okay.
like default namespace is not true. That's
Mm-hmm.
it. And then this is the message and the pattern.
Okay, so this is like warning of something rather
Correct.
than
And
error.
you will see the kind I have mentioned, the daemon set, deployment, job, and stateful set. These are the ways by which we
Okay,
deploy pod, right? So you'll see
correct,
these
correct.
are the kinds which it has mentioned. So if I'll try to deploy via these methods,
Hmm.
so it will
And
block.
if there is
So
no namespace, then it will fail. Not
correct.
fail. Sorry, it will
So
show a warning.
it will not even show me the warning. Let me just show. I'll first apply this one and then I'll
Hmm.
create the pod. So it is applied and now I'll create a pod. So you'll see it has created, it won't show us anything. But when I'll see the logs, for
Okay,
that I am installing the YQ, which is for the YAML,
okay.
and I'll quickly check which policy, the name of the policy and all.
Hmm.
I think there is no report. So
Okay.
it should be there.
We allowed the. Sorry, we
Let me see.
installed the policy, right? Or maybe we applied
Uh,
the policy. Yeah, we did.
I think we have applied.
Yeah, yeah, we applied. Oh, we haven't installed any pod or anything like that after that.
I think it took some time, so it might
Okay.
not be there in the, like it took some time to set up those
Okay, okay.
policies. See, it was installing in all the namespaces. The my warning might be there, I have ignored it.
Right, right.
uh, I'll add
So I see
warnings, I
there are
think it is
four
not there.
warnings. Yeah, I see four warnings now.
So I feel I can see in the default warning is not there, I think.
Oh, yeah, yeah. A
Yeah.
warning is not there. There are four
So
failures, but zero warnings. Do you want to run it again, maybe, just to see?
so I
Uh,
think the data is there. If you'll see, validation error using default namespace is not allowed.
okay.
So I think it has picked from all the pods which were running. You will see we did not
Mm-hmm.
delete the cube bench, right? And
Correct,
the
correct.
Kyverno Nginx pod. So I think see the Nginx audit pod we ran. So it is just showing for all the
Hmm.
values which
Right.
are
And the
already
result
running.
it says is fail,
Correct,
not warning.
correct.
So in your
So
earlier
the
report also there were four failures. So I guess it
correct.
matches.
Yes, yes, yes.
Yeah.
Okay. Now I'll delete this and I'll go to the
Okay.
last one, which is the mutation part.
Right. Yeah. I'm interested like what type of use cases mutations will be
So
used because you are changing it at runtime, right?
correct.
Like you don't have a trace of that in your, let's say,
Mhm.
source code or anywhere. It's
Correct.
getting updated at runtime.
So if
So
you'll
yeah,
see
let's look
here,
at that.
this time nothing is there. Like here, if you'll see, we had something of this validation failure action, right?
Right.
Because we are not
Right.
doing any kind of validation, so that is why there is no such thing. I'm just adding
Okay.
the rule name is add label, and then in the
Mm-hmm.
mutate section, I am just saying that patch strategic merge metadata label
Okay.
foobar. So I'm just extremely simple language that wherever
Mm-hmm.
label is there, just add a foobar label.
Okay.
So this basically a
So in a
policy I
way,
got it. Yeah, please continue.
sorry, in a way, you are applying some of the, let's say, you at org level, you have some labels that
Mhm.
you enforce for all of your clusters or all of
Correct.
your workloads, then you can
Mhm.
define policies so that developers, even though they might have forgotten, you
Correct.
have those labels applied.
Correct.
Okay, makes sense.
At broader level, we can have a match and then mutate label also. So this I got
Okay,
from the Kyverno library itself. So that is why I just
okay,
changed the label for the labs. Like we can have
okay,
much more advanced and granular policies, like where we are
okay,
checking like which pod it is, or maybe the development, if the label is development, then mutate or change it to the fail or something like that. Like, right.
okay.
Uh,
Right,
so
right.
it
So
it
you can
it
use
is
any selector that
correct.
Kubernetes supports, right? Could be
Correct.
label, could be pod related, anything, and then apply your mutations on top of it.
Correct. So I'll
Okay,
just I forgot to like create this add label.yaml. So I've created it and I'll apply this, basically run
sure,
it for
sure.
the first time, and it will
Yeah.
create the new mutation policy for me.
Okay.
And this time when I'll run, so you will see that I'm running a Python pod, and this time I'm not adding any label. So when
Okay.
I'll do a grep foo,
Mm-hmm.
basically I'm just showing quickly to, you will see the label has been added, foo equal to bar.
Hmm. Hmm. Right.
So this was added because we had a mutation policy.
Correct. Yeah. Makes sense.
So this is like, these are the extremely simple examples. They are much more complicated. So when I was creating the CTF lab, I have blocked
Mm-hmm.
the exact. I have blocked no default namespace is blocked. If someone is using node
Right.
name, like if
Mm-hmm.
for the bare clusters, if you will mention that I want to deploy my pod into the master node, right? So in though
Correct.
that is also possible. So I wanted to block all those things in the CTF. I wanted to have a specific path. So for those
Okay.
cases, I've explicitly created these no YAMLs, like Kyverno YAMLs from the library which I have got, because I am not very much expert in creating these
Mm-hmm.
YAML.
Okay.
So I was like, as I told you earlier, I was learning Rego, I was doing OPA, then immediately I have to shift to the Kyverno. So there were a couple of things, right? So I saw that this
Right.
is easy, just to change the name, the variables, and then use it
Mm-hmm.
for the
Right. Right.
personal use, or like anywhere if I want to use. Like they, most of the policies are present, so then you
Mm-hmm.
can just change the value and start using it, and later you can go to the more advanced policies, right? Once you have basic security in place, you can start
Mm-hmm.
using more advanced policies.
Right. Right. Yeah. So this is more for our audience. This is more like a quick start, right?
Correct.
How
Correct.
you can get started with
Correct.
Kyverno and what are the
Correct. Even
benefits?
these
How can you use it
policies.
for defending your
Correct.
cluster?
So even these policies, they are extremely important. Like default namespace is not allowed. That is one of the check, right? Adding the
Mm-hmm.
label, that should be mandatory, right? If we
Right.
want to segregate our resources, and Cilium actually works on the label. Like it uses label heavily. So you
Ah.
can,
Okay.
instead of using the IP address or the service, you can directly mention the label. Like all
Mm-hmm.
those pods with label maybe Nginx should not
Mm-hmm.
access the label Python or maybe
Okay.
Apache. So there the
Mm-hmm.
label is extremely required. So if you don't have labels there, you won't be able to enforce this no fabric or like these network policies via Cilium.
Okay. Okay. So labels are like the
Correct.
foundation in a way
Correct.
which you should have. Okay.
Correct. So now we'll jump to the Cilium very quickly. Cilium is a tool which uses eBPF, which is extended Berkeley packet filtering. So it
Mm-hmm.
filters packet on the kernel level to be extremely no, in the layman language. So
Yeah.
it basically injects bytecode into the kernel, and it tries to changes the network packet, or it monitors or like checks how the system calls are made.
Mm-hmm.
And because it is using this at the using eBPF at the kernel level, we can mostly use it for any network policy or anything we want, because now we have the
Right.
raw packet ability to monitor the raw packet or to capture the raw packet itself.
Right. Right. Yeah.
So Cilium also works in a similar way. I won't go into the details of how Cilium works.
Mm-hmm.
I like there also we have a Cilium daemon, which
Mm-hmm.
is the brain of Cilium, and it communicates with the Cilium CLI. Like we have kubectl for communicating to the Kube API server. Similarly, we have Cilium CLI. If you remember from the beginning, I used Cilium install to install the Cilium into the cluster.
Correct.
So Cilium is basically it provides a CLI.
Right.
Then here also we can have plugins and Cilium monitor, which is the Hubble UI, and in the backend you'll see the Cilium daemon is actually injecting the bytecode on the like Ethernet level, also on the container level also. So everywhere, because it
Okay.
is able to access the kernel, right? So because
Kernel
it is
level. Yeah,
accessing the
yeah.
kernel, so it is able to do the injection at no like very last point, and it can
Mm-hmm.
make changes or it can block the network traffic at that level.
Correct, correct. Okay.
So there is an agent of Cilium which is running on each node, which basically in charge
Mm-hmm.
of the rules and creating the connection with the Cube API server. Then there is an operator which manages all the tasks in the entire cluster. It
Okay.
won't take decisions about the network policy. It is for the installation or the upgradation of the Cilium on each node, or like whether the Cilium API server is working as expected or not. Then
Okay,
Cilium
okay. So it's
CLI is
management of Cilium
correct, correct.
itself. Okay.
And then Cilium CLI is our CLI, which is used to communicate to the Cilium, and then CNI
Mm-hmm.
plugin is basically our no the brain, or like the main part which will run our Cilium API server, which will
Okay.
basically communicate to API server, which will basically uh, from like when we'll use Cilium CLI, this is where we'll go and connect. So it is kind
Okay.
of like plugin, or you can say CRD, because
Mm-hmm.
not exactly it is, but it is like because we are installing it on the top of that, and we have a network, right? Until unless we don't have
Mm-hmm.
networking, our Kubernetes will stop working. Like it won't
Correct,
work.
correct.
Even
Yeah.
if I'll create a pod, they won't be in the running state.
Mm-hmm.
So that is why like we call it as a plugin, like because
Right.
it is configuring the network interfaces within the cluster.
Mm-hmm.
So
Makes
like
sense.
the as I mentioned, Hubble is the networking observability platform, and
Mm-hmm.
as I told you, you can see how your no like this policies, or how the Cilium policy which you have created are working. So you can
Okay.
use it. I have
And
not.
this will
Mhm.
be, sorry, Hubble will be hosted inside the cluster, right? Or do you have to
Correct.
use like
No, no,
Cilium Enterprise?
no. It is free of cost.
Okay. All right. So it's part of the cluster itself.
Correct.
The way you have like Kubernetes dashboard, let's say, if
Yes.
you enable
Yes.
it. Okay.
Correct.
All right.
So then directly move into the basics of Cilium, because that is a
Mm-hmm.
pretty big hands-on lab. So I'll first explain the scenario in a simpler way. I'll try to be as
Sure.
simple as possible. So I'm just skipping all these things, and
Mm-hmm. Yeah.
I'm not explaining all this. I'll directly jump and I'll see. Yeah. So I just wanted to have this thing. So there is a three. If you like, I am not much into this no Star Wars, so I don't know about these analogies. But people who know, they might be able to relate better. But because
Right.
students or no would come from different backgrounds, so everyone
Right.
like especially here, people are not aware of Star Wars. So in
Correct.
that case,
Correct.
I'll just give explanation that there is the Death Star, Imperial
Mm-hmm.
TIE Fighter, and Rebel X-wing. So these are the
Mm-hmm.
pods, I would say, which these are the microservices which are running. Let's
Okay.
assume that these are the microservices, and then
Okay.
actually they are the microservices here in this example. So
Okay.
then the next is the label. So there is one
Mm-hmm.
label org, which is Empire. Then there is another
Mm-hmm.
label class, which is Death Star.
Okay.
So Death Star is one microservice where no org for all the pods which are running this microservice. They have org equal to Empire, like label one,
Okay.
and then class equal to Death Star, which is label two. There are two labels,
Okay.
and
Mm-hmm.
then there is Imperial TIE Fighter service,
Mm-hmm.
or you will say a pod which is having
Mm-hmm.
all the pods within this microservice with the TIE Fighter will have org equal to Empire,
Same org.
but the
Okay.
class is TIE Fighter.
Okay.
So they have two labels. Org is similar in TIE Fighter and Death Star, but the class is different because like the
Mm-hmm.
microservice itself is different. Then
Correct.
there
Correct.
is
Yeah.
Rebel X-Wing. So for
Mm-hmm.
X-Wing, they have org equal to Alliance, and the class is
Mm-hmm.
X-Wing. So class is what kind of microservice it is, and org is like where they belong as the broader level. So you'll see Death Star and TIE Fighter, they are from the Empire org, and
Same org. Yeah.
Rebel X-Wing is opposite to them, like Alliance.
Mm-hmm.
So you can just assume that X-Wing is no attacker to the Death Star and Imperial TIE Fighter, right? That would be
Sure.
against both of them.
Uh-huh.
So like same has been mentioned, that deployment also includes a Death Star service which load balances traffic to all pods with label org Empire and class Death Star, right? That is
Okay.
like which we have discussed till now. So I'll
Mm-hmm.
create this demo application first.
Okay.
Let me see if I require something. Yeah, I'll open a new terminal,
Yeah.
because no, there are different directories, so I don't want to
Right.
have
Right.
a error this time. So it will
Correct.
create these deployments for me. You will see it
Okay.
will create a service Death Star. There is deployment and a service, right, for the Death Star,
Mm-hmm.
because Death Star
Mm-hmm.
service is used to load balance. And then there
Okay.
is this pod TIE fighter, and there this
And
pod
then pod
X-Wing.
XV.
Yeah.
Okay.
And I think there was a folder as well. I'll just quickly move to this folder.
Yeah. Let's do that.
Yeah, because I've already applied those things. So I'll just check whether the daemon set cilium is running or not. So you'll see daemon set cilium successfully rolled. So I have to roll out, like I have to tell that
Okay.
I'll be using cilium from now onwards. Okay.
Okay.
As a daemon set, so that is why I am just using this command, and I'm checking
Rollout
whether
command.
like
Okay.
status is there, or like is there or not. Then I'll
Sure.
apply or create the demo application. This is the YAML provided by the cilium team itself, so I'm not
Okay.
making any changes. And
Mm-hmm.
then kubectl get pod and svc just to check what pods and
Listing out.
services are running. Yes. So you
Okay.
will see there is pod Death Star, two pods, and there is one single pod with the TIE fighter and X-Wing name.
Mm. Right.
And we'll ignore other pods for now. I haven't
Yeah.
deleted
Yeah. Yeah.
that, so that is why it is present.
Yeah. Yeah. That
And
is okay.
yeah,
I see
so
one
I'll
Kyberno which is failing, but that was
yes,
part of the previous exercise, so we are
correct,
okay to
correct.
skip that.
So
Ignore
now
that.
we'll see this is the Cilium endpoints which are getting created. So Cilium
Okay.
endpoints are nothing but like what basically how Cilium will connect with these things. So you'll see there
Right.
is this
Okay.
core DNS, then there is this X-Wing TIE fighter,
Mm-hmm.
no, which is running on which port. So
Okay. Okay.
Cilium is kind of creating a mapping kind of a thing, so
Right.
that it
Within the
knows.
cluster.
Yes, correct, within the cluster. So now as we have seen, the name from the perspective
Mm-hmm.
of Death Star service, only ships with the label org equal to empire are allowed to connect and request the landing.
Okay.
So like there are two, no I'll go back to this. So there are TIE
Yeah. Yeah.
fighter and Rebel X-Wing and Death Star.
Correct.
So
Right.
only pod, or only basically only pod with org equal to empire should be able to access the Death Star microservice. This Rebel X-Wing
Mm-hmm.
should not be allowed. So
Right.
let's
Right.
see what is happening. So I'll do a curl, because they all are microservice. We have just given
Right.
them the name. So I'll do a curl here. So you will see it is
Mm-hmm.
saying ship landed. So I'm
Okay.
hitting
So
an
you could
API
connect
request
to
landing.
that.
Correct.
Right. Right.
So
Okay.
TIE fighter pod is able to access the Death Star API microservice,
Okay.
because org was empire in the case of TIE fighter
Correct.
also.
Correct.
Now
The
I
same
try
one.
to
Yeah.
access the X-Wing also. So
Mm-hmm.
you can see that here also the ship is landed, which is not the
Okay.
intended thing which we wanted. But because right now there is no network policy here, so that
Defined
is
yet.
why
Yeah.
yes, it is possible no to access the Death Star service. So now attacker can access this as well.
Correct. Correct.
So I'm not going into the description of that, as I've told you. Like we want to restrict the alliance, or this bad ships X-Wing to access the Death Star. So we'll have
Mm-hmm.
something similar where I'll say description restrict Death Star access to Empire ships, and then match
Okay.
label org equal to Empire and class it Death Star. So
Okay.
I'll say that only with the org Empire label and the class Death
Mm-hmm.
Star, like it should be allowed. So I'll quickly
Okay.
show this policy, and I'll open this, and I'll explain the policy as well.
Sure. Sure. And I think this is similar to what we did earlier, right? Where we looked
Correct,
at how we can restrict
correct.
communication between
So
pods.
here you
So
will
we are
see
doing something similar.
it is port 80 and the protocol is TCP, right? And
Ah.
the
Okay.
org label is Empire. So I am saying, like, to the org level Empire in the class Death Star, that is the name of the
Mm-hmm.
microservice. Like if we'll see, there is a way of writing the network policy or the Cilium policy. Whatever is
Ah.
below, right, from there
Mm-hmm.
the traffic is going to the top part. So you'll see I'm
Correct.
saying that match label org and Empire and the cloud Death Star, which is our microservice, and then
Right.
ingress match label org Empire. That means all the label services or pods with the label Empire should be able to do an ingress or able to access Empire and class Death Star. right? So
Correct, correct.
this
Okay.
this these two
That's like the
labels are present.
destination in a way,
Correct,
right? So
correct,
that's the
correct,
destination, and this is the source in a
correct,
way, how you are restricting it.
correct. And then the two port is port 80 and the TCP. So
Okay.
this is we have
So,
already applied. Mhm.
okay. So there are two sort types of restrictions we have applied, right? One is anything which is not part of that org empire
Correct.
will not
Mhm.
be able to access. The
Correct.
other is even though you are in empire and you are not using TCP and port 80, then also you will not be able to access.
Correct, correct. So
Okay.
usually these things I'll give to the students to test, like whether if they'll change the port, whether they are able to access or
Right,
not.
right.
So if you'll see here, this TIE fighter is able to access because they had this org equal to
Same
empire
org.
label. Correct. Now
Correct.
we'll again try to do via XWin, which were the alliance
Mm-hmm.
and they were the bad pod. So you'll see
Mm-hmm.
it would get stuck. The cull
It
won't
failed.
work. So we have successfully blocked. Now the next part of this lab was that no, we don't know that which, because there are thousands of TIE fighter planes or like thousands of
Correct.
pods
Correct.
running with the TIE, which with our TIE fighter microservice or pod with the org is equal to empire, but their
Mm-hmm.
class is not Death Star, right? They can access.
Right, right.
So suppose as an attacker I created a pod with the name of no with this X basically this
Same
X-Wing,
label and
yes, sorry, with TIE Fighter label, right?
correct.
TIE Fighter was having the two labels. Let me go to
Hmm.
the top and re-explain it. So you'll see TIE
Sure.
Fighter was having Org Empire in the class TIE Fighter.
TIE fighter. Yeah.
So these can be dynamic or ephemeral pods which anyone can deploy. Let's suppose that, right? And
Mm-hmm.
Death
Mm-hmm.
Star is our main microservice. So
Right.
because anyone can deploy the TIE Fighter, so as an attacker, I can deploy a TIE Fighter with an org equal to Empire.
Mm-hmm.
So now the next part will come. Okay, I was able to access, I was able to land. That is very good. Like that is not an issue because everyone is allowed with the org empire, whether it is an
Correct.
which we spy or not. But there was
Mm-hmm.
a hidden API which was present in the Death Star. So
Correct.
that hidden API causes denial of service, right? It crashes the
Okay.
microservice. So you will
Okay.
see when I did a curl on this no exhaust port, my it is
Mm-hmm.
saying panic.
Mm-hmm.
Sorry, Death Star exploded, which
Okay.
shows that our application failed or someone attacked it, right? So now
Correct.
I
Correct.
don't want my TIE fighter planes to access this specific endpoint. I want them
Okay.
to
So this is
land,
more
but
granular
correct, correct.
network policy in a way.
Correct.
Okay.
So now I'll mention that method post and the path is v1 request landing. So you'll see how
Okay.
simple the rule here is. Right. I'm
Uh-huh.
just again mentioning port 80 protocol and what kind of rule I want. So I just,
Right.
if I
Right.
want to create another policy, I'll just replace these values with the label I want and the values I want. Right.
Mm-hmm. Mm-hmm.
Sorry, I think I copied. So
Yeah.
there was this policy was already there.
Right. Okay.
So I'll create the new policy and we have
Mm-hmm.
already seen this policy, and
Right.
now I'll try to access this exhaust port which was the restricted, and now you'll see the access is denied.
Okay.
So this completes our cilium. Now if I'll as I always do, I'll just delete these policies. So this completes our all the critical things where we talked about the cilium, where we talked about no Kyberno, and we have
Mm-hmm.
the secrets. And the last thing I'll explain or I'll talk about the Istio service mesh.
Mm-hmm.
So service
Uh,
mesh
before
is
we before we
Mhm,
go into STO, I think
mhm,
what I saw with Cilium is very powerful, right? It
correct.
gives
Mhm,
you more granular ways
correct.
to control traffic between services, between
Mhm,
pods, based on different selectors.
correct.
Even at a L4 level, you can define.
Correct.
So yeah,
Correct.
makes a lot of sense, and I'm pretty sure our audience will find a lot of value out of it.
So the last part is I would talk about is service mesh. So I
Mm-hmm.
won't go deep into this, but I'll explain the idea and why we need this. No, maybe for the folks who are
Right.
getting started in the security, they can explore more, like Kubernetes security to be very specific. So
Right.
when we talk about microservice, right? So
Mm-hmm.
I have seen people worried about like how to like make sure that pod to pod communication is authenticated, or like there is an
Mm-hmm.
SSL between the no two microservices running. That is a major
Mm-hmm.
question which is coming from all the ways, like whoever is running their microservices. What we can do,
Mm-hmm.
like, so if they'll create an authentication and authorization mechanism for the microservices itself, and they will put that
Mm-hmm.
code in those same microservice, then their business logic won't like would work along with have to do more action, more work to make sure that communication is also working fine between the
Correct.
microservices. And
Right.
microservices will communicate a lot, right? There will be
Mm-hmm.
huge traffic. So what we can do, we can have an this called as service mesh or the proxy,
Mm-hmm.
which is a sidecar. So
Mm-hmm.
when we did kubectl get pods, right?
Right.
So there was only one pod running. You will see only one pod was running. So what we'll do, we'll enable this, inject this sidecar. We'll say that I want to inject the sidecars. So sidecar
Mm-hmm.
is nothing, there is another container which will run with the same pod. So in this
Okay.
pod now you will have two pods running, like for the each name.
Within the same.
Yes, within the
Yeah.
same
Okay.
pod. And inside
Mm-hmm.
that you will have one pod for the microservice or whatever service you want to run, and there would be a proxy pod as well.
Okay.
So this proxy pod will help in the communication. This proxy pod will help you in the SSL termination, SSL handshake and everything. This will help you in the authentication of, like, basically the communication which is happening between the microservices. So
Okay.
this sidecar will take care of all these things, and they have this
Mm-hmm.
Istio agent running which communicates to the Istio control plane. Again, the same
Okay.
concept, that there is one Istio daemon which is having all the access, and these agent will communicate to that no Istio um,
Yeah.
control
Makes
plane,
sense.
and they will communicate. So
Yeah.
because
So in a
all
way, you
the
are
Mhm.
abstracting all the
Correct.
work which is not core to the microservice to a proxy,
Mhm. Correct,
so that
correct,
developers can focus on only like
correct,
implementing their own
correct.
logic, right? Yeah.
Correct.
Okay.
So
Makes sense.
now, as a developer, they don't have to worry about the authentication. They'll create that application with the business logic, and
Right.
DevOps, or like we can go and deploy the sidecar, and that
Right.
will take care of all the things. So this is
Mm-hmm.
the next lab where we are deploying the Istio, and then we are deploying the application. I'm not going into
Okay.
the in that because there is
Mm-hmm.
nothing much to see. Like you won't be seeing anything, right? If you'll see the
Mm-hmm.
output, you will only have something similar, right? If you'll see there is 2 by 2 pod, which I told you,
Oh,
like there
right.
is a
Right.
sidecar is
Right.
there, and we'll check. No, it will also help in the ingress gateway how the traffic is communicated, because earlier the traffic would directly hit your microservices, right?
Mm-hmm.
But in this case, now the traffic would be forwarded via Istio. So we have to tell the Kubernetes
Okay.
cluster that my service is ingress gateway. This Istio is my now main service, and you have to
Okay.
hit send everything to ingress this Istio gateway or the
And
Istio
then that
service,
would do
and
the routing.
correct, that would do the routing
Okay.
for us.
Makes
So
sense.
this is pretty much it. There was nothing more. So I'm not just going inside that. I just want to
Okay.
show one last thing. Yes. So
Mm-hmm.
I won't go again. I won't get inside. I'll explain this Kiali dashboard. So because we have installed the Istio, so there is a add-ons or the extensions, as we are always talking
Mm-hmm.
about the extensions. So there is similar set of extensions provided by this Istio, which is
Okay.
Kiali, Prometheus, Grafana, and Tracing, Jaeger,
Jagger and yeah, yeah.
Zipkin. So all these things, they are there. So like if we'll do an it is present in the default directory which we have, or like if we'll download. So
Okay.
in the samples in the add-on, they have all these no pods or services, everything is there. You just have to go and kubectl apply. If you want
Okay.
to
Okay.
deploy something specific like Grafana, then you have to select those YAMLs only. So it depends,
Mm-hmm.
right? Because it is a staging or testing cluster, then I'll deploy everything. And then for and
Yeah.
here I am explicitly deploying the Kiali service. So it is an
Okay.
UI which helps in the
Mm-hmm.
monitoring. As I'm always talking, like how we can do the monitoring, how we can do the monitoring. This is how it is. So once you have the Istio, because sidecar is
Mm-hmm.
taking care of everything, all the traffic and
Right. Right.
networking, right? So now
Mm-hmm.
we can use this dashboard to look how the traffic is flowing. So if
Okay.
there would be a blocker in the traffic, or from microservice 1 traffic is not going to microservice 2, and because it is managed by the sidecar, so sidecar would immediately send everything to this Kiali dashboard, and the UI we will be able to
Okay.
see that it is no blocked, or it is in red color. So
Allowed and
like
okay.
correct. So usually this was the lab. It would look something similar, and you will have a graph with the flow also. So if someone will
Okay.
keep hitting microservice 1 and it is communicating to microservice 2 internally, it will show all
Mm-hmm.
green. it will show idle state also, and all those things which nodes are
Okay.
pods are idle. So all these things, this will come in the Kiali. So
Okay.
this brings
Makes
us to
sense.
the end of Kubernetes defense. I'm not going into more deep. Like this is for a beginner level workshop. This is like more than that. So
Mhm.
we'll stick
No,
to
this
this.
in yeah, yeah, this in itself has a lot to learn.
Correct, correct,
Like starting from your
correct.
secrets management to your network policies, all of that. So I can, like, I personally have learned quite a few things as part of the exercise. So
So
thank you for
every
doing
time
it.
even I'll do that, right? I'll think in a new way. Okay, this like the policy is network policy, that pattern. So I knew
Hmm.
this is working, but I never explained in that way. So for me also
Right.
it was okay. I can explain in this way, that it would be easy, because if you are reading from top to bottom, then you
Hmm.
won't, like for the first timer it would be difficult to understand, right? Like from where to
Right.
where the flow is. But if I'll explain that you have to read it from bottom to top, then this becomes
Hmm.
like source to destination becomes much easy. So for me
Correct.
also,
Correct.
it is every time I'll get a new way of explaining things.
Okay. Yeah. No. No. Absolutely. That's understandable. So I have few questions before we
Hmm.
close
Sure.
the session.
Hmm.
So one is, the last time when we looked at the attack side, right?
Hmm.
We had a remote code execution issue, and
Hmm.
you could exploit it and take over the cluster. So
Hmm.
as a let's say blue team or a team trying to defend it,
Hmm.
what options do I have to close that gap? Is it the code scanning? Is it the
Hmm.
cluster scanning? What can I do to address that gap?
So there would be multiple ways of doing it. I'll start from the code scanning or from the first I'll talk about the external point, and once we'll reach the
Okay.
application, I'll talk about the code scanning part. So from the
Okay.
external point, we should have a firewall in place, so that
Okay.
it blocks the basic attacks. Like if we have some cloud based firewall, I'm not naming the vendor, because firewalls can be bypassed easily. So if you have some no like next gen firewalls, or like specifically the Cloudflare, then you it will block more attacks,
Correct.
because that
Correct.
is capable of doing much more things. So you that would block most of the attacks, this reverse shell or XSS or RC or SSRF. If that is not there, like bypasses can happen. So if attacker would
Mm-hmm.
bypass, the next step would be no. If you remember, I tried to get a reverse shell or try to run the commands. I try to check
Mm-hmm.
for different binaries, right? Or I
Right.
try to do the env or those things. So if they are not required, we can explicitly block those commands. Like env is a command which anyway we can't block much, but
Right.
like
Right.
access to etc pass wd or the log file or like the cat binary,
Uh,
those things we can remove. Like we can have a cluster image which is extremely hardened, right, where we don't
mm-hmm.
have any redundant binary, like curl and wget is not present, or like the python 3 is not present. We
Right.
need to keep
Right.
only things which are required, but anyway it would leave a gap, that it would be running some like no language, like it can be java, it can be
Mm-hmm.
python, it can be go. So that language would be there. So
Correct. Correct.
hardening it to the level that only that part of the jar is running in case of java, or that folder is running, is extremely difficult. So what we
Right.
can do, we can instead block the temp folder, right, where the
Mm-hmm.
attacker would try to create the shell and try to run that command, because they have to create a file and then they'll try to do a
Right.
python, like no, or
Right.
they'll directly try to run a command even without saving. Also in those cases we can block on the network level, like on the vpc
Mm-hmm.
level. Like outbound is always open. I've seen most of the organization, they have outbound open, because they
Correct.
think that is not an issue. But in case of reverse shells, for me that was easy. Like whenever I would do an internal red team assessment, because
Mm-hmm.
outbound is open, so I'll take a reverse shell onto my local, and then for me it is very easy, right?
Correct.
I'm
Correct.
not naming the services. Like if I'll name, everyone can try to like do pen test on those services, and without permission, that is not like healthy. Because if you'll do those on
Right.
production environments, then like anything can go wrong. So
Mm-hmm.
those services, like let's assume xyz services, and you know that you can run commands of those services. It can be any no functionality or specific to devops team which they have created for some no
Mm-hmm.
key adding purpose. Like teams would create different tools. So right, if
Right.
we have something similar and you are inside the container, so because outbound is always open in those cases, so I'll create an
Mm-hmm.
ec2 and I'll take a reversal, because they are getting a public ip is much easier than getting onto my local, because in my local I have
Correct.
to
Correct.
port forward and everything, right? So there I'll directly
Right.
do a
Right.
public ip and I'll get access to my personal ec2 instance. So because
Right.
outbound at 0.0 is open, so we can block that. Then we can have a specific port open, like 44380, because applications would be running only to those specific ports. like although network
Exactly.
traffic flow would happen, like the inbound to the outbound can happen via any port, so we can't block all the things, but we can have a restriction, right? Like it is not always
Yeah, yeah.
recommended to block and restrict everything. Like some
Hmm.
level of something would eventually block the attack. Like even then, if
Correct.
attacker was able to get the reverse shell, like if I remove the basic commands like curl I will remove, or like these commands I will remove, or my user basically my quad is not running as root, in that
Hmm.
case like I don't have access to temp because we have already blocked it. Then no, my containers is running as root non-root, or it is not having capabilities, then I won't be
Hmm.
able to use the apt update, I won't be able to install anything, I won't be able to
Correct. Correct.
download anything, because curl and
Hmm.
all is not there. Even if I'll download, like suppose I have downloaded, somehow I was able to do, like get the maybe base 64 I'll use, like if I'll talk
Hmm.
about the obfuscation, I'll use base
Right.
64 and I'll copy paste. So if base 64 binary itself is not there, I can't do anything,
Correct.
because
Exactly.
curl and wget is also not there. We might be using python 3 or python or java in those cases to have that, but it would make things difficult for an no script
For
kiddie
an
or for
attacker.
any
Yeah.
attacker.
Yeah.
For any attacker,
Yeah.
they have to think, like they have to stay for that long in that cluster or in that pod, right?
Hmm.
So which will make detection easier. If we have sim solution
Yeah.
or
Yeah.
we are logging EKs, then by that time it would be detected, right? Because they will try
Right.
so many things in that cluster.
Hmm.
So
Yeah.
the
Yeah.
by default they would be forced, like to get detected. There is no way like they will get undetected, because we have
Right.
hardened it so much. Plus
Hmm.
even if they have got access to one pod, we have to make sure that they don't have access to secrets or services or s3 buckets, or they
Yeah.
have
Yeah.
specific permissions attached, like with that no containers. So for that also they need something, like they need curl
Yeah.
or they need aws cli, right? Like
Hmm.
they will need some way to connect, they will need python 3 maybe to install the aws cli, like something, some more permissions
Correct.
they
Yeah.
would
Yeah.
require.
Yeah. So the
So if
more
that, hmm,
restrictive
correct,
your
environment is
setup is, environment
correct,
is, like in terms of hardened image or blocking paths or
correct,
not allowing processes,
correct.
that helps from an outside in. What about
Correct.
inside? Let's say you have access to the code.
Mhm.
What can you do
Oh,
for remote code
so
execution?
for inside, I won't need RC for much because I anyway have access. But in that case, also like as an insider, what I'll do, I'll try to do an exec into that pod, right? Because I have
Hmm.
access. Or even if I'm in one pod, I'll try to do an exec into another pod. So I can use a Kyverno to block exec command itself. So like Docker exec or kubectl
Right.
exec is command, as you saw when we were running
Hmm.
curl, we were using exec to run that command. So if I'll
Right.
block that command itself, it will block everything, right? Even if I have access
Right.
to X container, I won't be able to exec inside the Y or Z containers. So it
Yeah.
would
Yeah.
restrict.
Makes sense.
And if you will combine all these things, right? Namespace
Hmm.
blocking, exec blocking, then network blocking. So now you'll see how restrictive this all these things are. So at some level, you can have Kyverno itself to protect from this exec or no maybe attacker, because he is not having permission to deploy anything, or the user is like non-root user.
Hmm.
So attacker can try to deploy another pod. So
Right.
even if I'll block pod deployment also, so those things via like kubectl, or those things like if it is getting into a default namespace, because if that
Hmm.
pod is not having permission to get namespace, then attacker would
Hmm.
try to brute force what namespaces are present,
Exactly.
or where
Yeah.
I
Yeah.
can deploy like the system namespace which are present by default also. If we will block
Hmm.
those also, then like again it would be more restrictive, right? This is something where you
Yeah.
have to see how your cluster is created and what you can do to bypass
Hmm.
those things. Like I have seen my cluster and then I started bypassing whatever you are asking. Then I
Right.
created the Kyverno policy, then implemented in the staging, and then tried to bypass again. Till the point I was not able to bypass.
Okay.
So
That
there
that
were
makes sense.
correct. So this
Uh,
is how, and then last part is your code scanning. So for code
right.
scanning, definitely we can try like any code scanner, which will give us the basic idea. If you want to go
Hmm.
for any free, and if paid is there, they will have like your flow sync and source also, how the flow of data is happening. But most
Right.
of the vulnerable functions are very common, right? OS
Hmm.
system, open, p open. So all these things, like at least I know about Python, so they are very easy to like figure out. Like
Detected. Yeah. Yeah. They
correct.
can be
So they
detected.
are easily
So
detected. So mhm,
yeah, yeah. So one thing that you highlighted is the permissions, right?
mhm,
So in the earlier attack episode, we saw that we had a we had a like policy
Correct.
defined where the
Mm-hmm.
permission was star dot star,
Mm-hmm.
which is not recommended, right? Again,
Correct. Correct.
even on the cloud infrastructure, that is not
Correct.
recommended. We always follow
Correct.
least
Correct.
privilege and all of that.
Correct.
How
Correct.
would you do that in a Kubernetes cluster setup?
So I was coming to that. So once we have code and everything sorted, last part
Mm-hmm.
would be your infra deployment thing, because infra
Right.
is getting deployed. So it would be RBACs, your services, and all those things like YAML
Right.
part. And the second
Mm-hmm.
would be your Terraform part, which will basically
Mm-hmm.
create the AWS environment or GCP environment for running that cluster. So we have to
Exactly.
make sure they are not vulnerable. Like if I'll drop everything, all those capabilities, basically we have to add those drop functionalities non-root in the YAML itself, right? It won't be on the
Right.
container level. So we have to
Huh,
scan
huh.
those YAMLs and find out automatically, like via TFSec for Terraform and Checkov via automated whenever the code is pushed via GitHub Actions maybe, and check
Right.
what kind of misconfigurations are present in these YAMLs. And
Mm-hmm.
same is for the RBAC, but for the RBAC we have to keep it specific to RBAC. Like Checkov will scan everything. We should
Mm-hmm.
make sure that we are explicitly doing an audit of RBAC. Plus, some
Okay.
organizations use no third-party tools like Rancher or something to manage these
Mm-hmm.
RBACs from the UI. So there
Right.
also we need to check those tools from which allows these access. No, whether that
Ah.
X user is having permission or not, or from the UI if they are managing. Like whichever ways they are using, first we have to collect those ways as an internal security engineer to find out
Okay.
maybe like permissions, what everything, like how the no cluster access is given. Is it the
Mm-hmm.
certificate based, or like everyone using the admin keys, or like the config is shared between no each user? There is no specific user based user, or is it just a non no like is it the machine user like Ubuntu or something like EC2 instance, or some
Right.
similar users are there which are not human users. So we have to keep check on the RBAC part, explicitly auditing that, plus the YAML part and the Terraform part, or like whichever
Okay.
way, like if Ansible is used, then
You are deploying.
how
Right.
correct how the deployment is happening. And
Okay.
then last part is the monitoring, which is also extremely important, though very costly. So to monitor the logs, you need to generate the logs of the cluster and then push it into the SIM solution or any ELK stack, which is very
Right. Right.
costly. So instead of that, we can have this Falco or Threat Mapper or any runtime security tool if people want to go for the paid one, to have those
Mm-hmm.
things. And basically, to have that in the runtime, it would run similarly to what how the Kyverno or the Cilium were running within the cluster.
Mm-hmm.
If you don't want to run on as an agent or as a sidecar, then we can have one single pod running in the cluster, which will
Right.
scan and which will do all kind of activities, and it will also keep an eye. It will give you all the data which is or how the communication is happening. So it also having
Okay.
some pods, when they are created via YAML, they will ask for more permissions. Like they will try to have whole structure. They will try to basically get the kernel level access, because they
Mm-hmm.
try to inject runtime security, and they will block etc pass wd command or those kind
Right.
of commands running within the cluster. Like, but
Right.
they
Right.
will need explicit permissions to do that. So you have to make sure that you are getting those permissions, you are reviewing those permissions, third party tools, before you are deploying it, because memory issue can be one, and the second is if they are having some external permission and tomorrow the tool or that company itself is hacked, right?
Correct.
Then
Correct.
attacker
Vulnerable,
would have
then
access.
you
Correct.
become
Correct.
exactly. Okay, that makes
So
sense. So we
this is
covered
how
three
we
things,
will do
right?
it. Mm-hmm.
Yeah, we covered
Yes.
from an outside perspective. What are
Correct.
the things like firewall, hardened images, all of those,
Mm-hmm.
and then you can do code scan, infra security like RBAC
Correct.
scans, and then
Mm-hmm.
monitoring aspect, runtime monitoring aspects. So yeah, that's a great way to sort of end the episode, right? We covered
Right.
all the
Right.
attack vectors. Now we covered few of the defense vectors as well. So yeah, thank you so much,
Thank you.
Divyanshu, for coming
Yeah.
to the show and
Thank you.
sharing your knowledge around Kubernetes, both from an attacker perspective and also from a defense perspective.
Yeah. Thank you. So I'm stopping the screen share first.
Yeah. Uh, Thank you,
So,
and to our viewers, thank you for watching. Hope you learned something new. If you have any questions, share those at scale20.com, and we'll get those answered by an expert in the security
and
space.
please share the
Thank you so much.
feedback also if you have. Like I might be very fast because of the time. So and I know that I'm working on it, but due to obviously time constraint, I was moving in a faster way. So if we have more time, we can have maybe more sessions. And I just want to add, I'm giving one training, so there also I'm not naming it here, but in
Yeah.
that training, you guys can come if someone is really interested. Then it would be a 3 day long training, no, and there you
Oh
can have
wow.
better idea about what kind of how these things work, and we'll go through each of these functionalities or YAMLs separately. And then it would be like a larger lab where we'll check, we'll try to create, we'll do more things, but we'll have more time. That is
Yeah, yeah. Makes
so
sense. So this is more of an introduction to
correct, correct,
Kubernetes and the
correct,
attack and defense side, right? Yeah, the workshop makes absolutely a lot of sense, where folks can go in detail and you can guide them as well.
correct.
Yeah. All
So
right.
that's pretty
Thank
much
you
it.
so
Yeah,
much for joining again,
yeah.
and
And
thank you, everyone.
thank you, Purushottam, for having me. Bye, bye, guys.
Thank you, Divyanshu, for this amazing workshop. There were quite a few things to learn for me. I hope our audience would love and learn something from this workshop. With this, we conclude our workshop. If you have any questions around security, share those at scale20.com and we'll get those answered by an expert in the security space. See you in our next episode. Thank you.